Welcome to Course 8 of the Oregon Third-Party Verification Training. This presentation is specifically tailored for verification service providers working in Oregon. Today, we will cover verification strategies for specific process emissions, focusing on unique aspects pertinent to Oregon. This presentation is designed for verification service providers interested in emissions verification process for specific subparts under 40 CFR 98 and one unique calculation methodology in Oregon. It is important to note that one facility in Oregon utilizes fluorinated greenhouse gases as blowing agents in extruded polystyrene foam insulation manufacturing process. As a reminder, the information presented in these slides does not replace the verifier's responsibility to know and abide by DEQ's greenhouse gas reporting program and third-party verification regulations. Please read the regulations, and if any information conflicts, the regulation takes precedence. The agenda includes a review of verification strategies under Subpart G, ammonia manufacturing, Subpart I, electronics manufacturing, Subpart AA, pulp and paper manufacturing, Subpart PP, suppliers of carbon dioxide, and foam blowing operations. We will go over each subpart's applicability, emissions calculation methods, and specific considerations for verifiers. The State of Oregon Administrative Rule 342.15 references 40 CFR 98 for calculation methodology only. The reporting applicability described in 40 CFR 98 is not referenced in Oregon Rule. Applicability for greenhouse gas emissions reporting in Oregon is described in OAR 340.215.30. We will begin with an introduction to Subpart G of 40 CFR 98, which is tailored specifically for ammonia manufacturing. The section covers emissions reporting requirements and applicability, regulatory framework details, and emphasizes information that verifiers of reports with emissions estimated under this subpart should be aware of when verifying greenhouse gas emissions reports in Oregon. Verifiers should review and be familiar with the calculation methodology guidance found in 40 CFR 98 on all subparts discussed in these courses, as well as the Oregon-specific rules described in OAR 342.15 and OAR 342.72. This slide effectively summarizes the key points about emissions reporting in ammonia manufacturing, highlighting the different subparts and types of emissions covered under 40 CFR 98. The ammonia producing facility in Oregon does capture CO2 that is later used for on-site urea production. Ammonia is commonly produced from fossil fuels, such as natural gas, coal, and oil, using the Haber-Bosch process. Natural gas is the most popular feedstock and is what is used in Oregon. In this process, natural gas is used as both an energy source and a hydrogen feedstock to capture nitrogen from the air and bind it to hydrogen atoms. The feedstocks are usually gasified to create synthesis gas, carbon monoxide and hydrogen, which is then reacted with water and nitrogen to produce ammonia. Producers of ammonia are required to report the process emissions under Subpart G, the combustion emissions under Subpart C, and any CO2 transferred offsite under Subpart PP. There are two different methods specified in Subpart G for estimating emissions from ammonia production. The ammonia production facility in Oregon estimates their emissions through the carbon content of the feedstock and the applicable equation. Since the ammonia production facility in Oregon produces ammonia from natural gas, equation G1 is utilized to estimate the reported greenhouse gas emissions under Subpart G. This slide shows equation G1, which provides a clear formula for calculating annual CO2 emissions from gaseous feedstock, along with explanations of each variable involved in the calculation. Here we can review equation G5, which provides a concise formula and explanation for calculating the annual combined CO2 emissions from multiple ammonia processing units. Verifiers should be aware of the steps and considerations involved in verifying greenhouse gas emissions from ammonia production facilities. This slide emphasizes the importance of accurate data, proper calculation methods, and adherence to regulatory requirements for greenhouse gas emissions reporting. Here we can see specific guidance on how to handle missing data in CO2 emissions calculations for ammonia production facilities, emphasizing compliance with 40 CFR 98 and the best practices for data substitution. To ensure a thorough and accurate verification process, it is essential to follow a detailed checklist of site visit procedures. This slide contains some, but not all, procedures that should be followed on a site visit when verifying a greenhouse gas emissions report for a source that produces ammonia. Next, we'll be discussing emissions reported under Subpart I, electronics manufacturing. This section outlines key components, regulatory compliance requirements, sector-specific challenges, and verification best practices of greenhouse gas emissions reports from sources that manufacture electronics. I would like to highlight the facilities in Oregon that report Subpart I emissions requiring third-party verification. Verifiers should be aware of the specific reporting requirements described in 40 CFR Part 98 Subpart I, and that there are fluorinated greenhouse gases used in the electronics manufacturing process that are not listed in Table I2 of Subpart I. These chemicals may be listed in Table A1 to Subpart A of 40 CFR 98 and should be included in the calculations. Reporters calculate total annual emissions of each fluorinated greenhouse gas for each production process. They can use default utilization and byproduct formation rates or stack test methods to estimate emissions accurately. Annual emissions calculations must include each fluorinated greenhouse gas for each process type and chamber cleaning, nitrous oxide for chemical vapor deposition, heat transfer fluids, and any stationary combustion units. This comprehensive approach ensures all greenhouse gas emissions are accounted for. Subpart I calculations consider specific consumption, process utilization, gas flow to abatement devices, and abatement effectiveness. Byproduct emissions also factor in formation rates and abatement efficiencies. There are default emissions factors for various wafer sizes and process types. Verifiers should be aware of these default values for different wafer sizes and process types to ensure reporters are using the correct default emissions factors and byproduct formation rates in their calculations. This slide directs us to specific information regarding nitrous oxide emissions. For default emission factors related to nitrous oxide utilization when calculating annual emissions, please refer to Table I8. It is important to note that there are no specific byproduct emissions factors applicable to annual nitrous oxide emissions. Here we see equation I6 of 40 CFR 98 introduced with a key for the equation inputs. Equation I6 is used to estimate the emissions of input gas and each byproduct gas from a specific process type on a fab basis in metric tons. Here we see equation I8 of 40 CFR 98 introduced with a key for the equation inputs. Equation I8 is used to estimate the annual fab level emissions of each fluorinated greenhouse gas used for the specific plasma etching, wafer cleaning process types that are being used. Multiple equations exist for calculating emissions with Subpart I methodology, and it is crucial to ensure that all equations being used are the correct equations and the calculations are accurate. To achieve this, it is best practice to consult 40 CFR 98.93, which includes equations I6 through I24b. These equations are designed to account for all variable inputs and provide a thorough and precise calculation of GHG emissions. Verifiers should review all gas and heat transfer fluid purchasing records and invoices and compare them to the facility's gas inventories. In the event of missing data, it is important to follow the procedures outlined in 40 CFR 98.95 for estimating missing data. This ensures that any gaps in the data are filled accurately and in compliance with the regulatory standards. To verify greenhouse gas emissions from electronics manufacturing, ensure company records are complete and accurate. Request an unredacted version of the EPA GHG emissions report. Verify correct data inputs and equations, and ensure all QA/QC requirements are met. Recalculate emissions using the company's own data to confirm accuracy. During site visits, review and follow all safety guidance provided by the facility. Check all data inputs used for emissions calculation. Observe metering devices. Check calibration records. Visit all emissions unit and review fuel, fluorinated gas, and heat transfer fluid purchasing receipts and invoices. Also, review production records and compare to previous year's records. To ensure a thorough and accurate verification process, it is essential to follow a detailed checklist of procedures. This slide contains some, but not all procedures that should be followed when verifying a greenhouse gas emission report for source of reports under Subpart I, 40 CFR 98 methodology. It is recommended that verifiers construct a comprehensive checklist to ensure that the verification process is thorough and accurate. We will now discuss reports from sources that report under Subpart AA, pulp and paper manufacturing. This section outlines key components, regulatory compliance requirements, specific challenges, and verification best practices for sources that report greenhouse gas emissions under Subpart AA. Facilities must report CO2, biogenic CO2, methane, and nitrous oxide emissions from each chemical recovery furnace, combustion unit, and lime kiln. Additionally, CO2 emissions from the addition of makeup chemicals in chemical recovery areas and combustion emissions from each stationary combustion unit must be reported. To calculate greenhouse gas emissions, use direct measurement of fossil fuels consumed, default or site-specific high heat values, and default emissions factors according to Tier 1, 2, or 3 methodology for stationary combustion sources. Ensure all required variables are accounted for, including emissions factors, high heat values, and fuel totals. Calculate biogenic CO2 and byproduct emissions from biomass using measured quantities of spent liquor solids, fired, site-specific high heat value, default emissions factors, or the carbon content of the spent liquor solids. Use equation AA1 or AA2 depending on the data available. Equation AA1 will be used at least once to calculate greenhouse gas emissions under the subpart. When calculating biogenic emissions, use measured quantities of spent liquor solids, site-specific high heat values, and default emissions factors. Equation AA1 includes biogenic emissions from the conversion of calcium carbonate to calcium oxide in the lime kiln. For sulfide or standalone semi-chemical facilities, use equation AA2. Solids are the mass of spent liquor solids combusted, and CC is a carbon content of the spent liquor solids. For makeup chemical use, calculate CO2 emissions by measuring the quantity of chemicals added and using the molecular weights of CO2 makeup chemicals as directed by equation AA3. Ensure all QA/QC procedures are followed according to 40 CFR 98.274. Follow missing data procedures described in 40 CFR 98.275 for estimating missing data. Read the sections in detail for specific information on QA/QC procedures for inputs into equations AA1, AA2, and AA3. Request unredacted versions of all EPA EGRET reports. Ensure that all data elements are correctly input into YDO. Review all company records used in initial calculations and request all data inputs needed to recalculate emissions. Recalculate emissions using Tier 1 calculation methodologies and equations AA1, AA2, or AA3 as appropriate to cross-check the calculations. During site visits, review and follow all safety guidance provided by the facility, check all data inputs used for emissions calculations, observe metering devices, check calibration records, visit all emissions units, review fuel and chemical purchasing receipts and invoices, and review production records and compare to previous year's records, noting any anomalies. Next, we will be discussing subpart PP, suppliers of carbon dioxide. This section outlines key components, regulatory compliance requirements, sector-specific challenges, and verification best practices. A carbon dioxide supplier is defined as a facility that captures, extracts, or produces CO2 for on-site commercial application or to supply to another entity. This definition does not include transportation, distribution, purification, compression, or processing of CO2. This category does not cover storage of CO2 above ground or in geological formations, enhanced oil and gas recovery, transportation or distribution of CO2, purification, compression, or processing of CO2, on-site use of captured CO2 or CO2 in equipment like fire extinguishers. Currently, 2 facilities in Oregon report greenhouse gas emissions using the methodology in subpart PP, Dyno Nobel and Alto Ingredients. The following greenhouse gases must be reported: the mass of CO2 captured from the production process units, mass extracted CO2 from production wells, and mass imported and mass exported CO2. Subpart PP includes 5 equations for estimating the emissions from CO2 suppliers. Reporters calculate quarterly the mass of CO2 in a CO2 stream using specific equations based on mass flow and composition data. To aggregate data, reporters use either equation PP3A or PP3B, depending on whether the CO2 stream is measured before or after segregation. For importers or exporters of CO2 in containers, equation PP4 is used to calculate the total mass of CO2 based on weight bills, scales, or load cells. Ensure all QA/QC procedures from 98.424 are followed, and missing data procedures from 40 CFR 98.425 are used to estimate any missing data. During site visits, review and follow all safety guidance provided by the facility. Check all data inputs used for emissions calculations, observe metering devices, and check calibration records. Finally, we will discuss foam blowing operations in Oregon. Oregon has a specific reporting methodology for foam blowing operations detailed in Oregon Administrative Rule 340, 215, 105-6. There is only one foam blowing facility in Oregon, Owens Corning Corporation, a polystyrene foam product manufacturing facility located in Gresham. Report the total mass of each fluorinated greenhouse gas in pre-charged equipment or closed cell foams. For pre-charged equipment, report the identity of the fluorinated greenhouse gas charge size, holding charge, and number produced. For closed cell foams, report the identity of the fluorinated greenhouse gas, its density, and the volume of foam produced. Calculate greenhouse gas emissions from foam blowing operations using the provided equation from Oregon Administrative Rule 340, 215, 105-6. When using a blend of gases, calculate emissions separately for each constituent. The equation converts pounds to metric tons and incorporates the global warming potential for each fluorinated greenhouse gas. Currently, there are no prescribed QA/QC procedures for foam blowing operations in the state of Oregon. Contact DEQ staff for guidance on best practices if missing data is encountered. Request off-gassing curves, variable inputs in equations, purchasing records of all fluorinated greenhouse gases, laboratory reports, calibration records, and the amount and types of products produced. Ensure inputs and outputs match on a scale of magnitude. This concludes the course date of the Greenhouse Gas Reporting Program Third-Party Verification Training. Thank you for attending today's training on third-party verification for permitted sources that report greenhouse gas emissions using calculation methodology from selected subparts to 40 CFR 98. If you have any questions, please email us at 3pverify@deq.oregon.gov.